Hello everybody, this is the notes for section 3.3. We are going to take a break for one section at least, dealing with the systems, because we got to talk about linear inequalities. Okay, we're not talking about a system of inequalities, just linear inequalities. Instead of an equation where it's 3x plus 4y equals 5, we're throwing in an inequality. And we're going to talk about how to graph it, how to recognize where to shade it, and all this other stuff. So, just as a kind of lead-in, the name of the section was linear inequalities with two variables. So let's just talk about one variable. So up here at the top, if we wanted to solve this inequality, just solve it like normal. We're going to subtract 7 from both sides, giving us a -6. Divide both sides by a +2. We get x values less than or equal to -3. Now when we graph it, we go to the number line. It's an or equal to. So we're going to fill that circle in, and we have x values less than that. That's this way, okay? When you start dealing with, and so only one variable, only one number line. When you start dealing with a linear inequality in two variables, now you've got an x-axis and a y-axis. So when you graph a line, I'm trying to move this stuff out here so you can see a little bit better. When you graph a line, you're going to get an ordered pair. You have an x and a y value. But
Staff, this is a quick reminder that we have a coordinate.
Okay, sorry. It was an announcement for something. When you're graphing a line, and we start talking about inequalities, you're going to have a whole bunch of points. Just like on the number line up here, we got a whole bunch of values of x that satisfy that inequality. With two variables, we're going to have a whole bunch of coordinates, x and y values that satisfy the inequality. So up here, we started at a number and shaded on one side. Same idea with a linear inequality with two variables. We have our line, but then we're shading on one side of it. So anything in this yellow shaded space, any of those coordinates satisfies that inequality. All right, so to graph them, take a second, hit pause, copy this stuff down. Okay, when you are graphing them, you got a couple of things to worry about. And the book goes through a lot more detail, and I'll talk about it here, but this is more concise and it works for everything. When you're graphing, pay attention to the inequality symbol. If there is no or equal to, it's dashed. If you have the or equal to's, solid line. So you're just graphing the equation for the line. To know which side of the line to shade on, you are going to test a point. Pick a point not on the line, plug it in. If the point that you tested makes that inequality true, you're going to shade on that side. Whatever side. Just another announcement. Sorry, I had to hit pause. Too many people have the code to make all calls. Pick a point, test it. If it makes the inequality true, whatever side of the line that point is on, that's the side you shade. If that point you tested makes the inequality false, whatever side of that line the point was on, you're going to shade on the other side. So let's do this problem as an example. To graph this one, it's basically in standard form. So again, I'm just going to pretend it's an equal sign. I am going to have a dashed line because it is not an or equal to. So x-intercept, we got a -5x equals 4. The x-intercept is going to be a -4/5. Just plug in 0 for y. For the y-intercept, I got a -2y equals 4, so y is -2. All right, these are the things we talked about in chapter 1. Y-intercept, -2, x-intercept, -4/5, somewhere around here. It's a dashed line going through those 2 points. And now we're going to shade on one side or the other. The easiest point to test is the origin. Again, test any point you want as long as that point's not on the line. So I'm going to plug in 0 and 0 for x and y. 0 minus 0. Is 0 greater than 4? No, it's not. So that is false. Okay, 0, 0, that point is above the green line. We plugged in that coordinate, it made it false. We are going to shade below the line. And this is all you really need to do for the shading. You don't have to be super detailed like you're coloring in a picture. That's perfectly acceptable. Okay, that's how you graph a linear inequality. All right. So there is a quicker way if the equations are in that y equals mx plus b form. But you're still going to do the same kind of thing. Graph that line like it's a equation. So we've got a y-intercept of -2. We're looking at the one on the left here. You got a slope of -2. So going down 2 over +1, it's not an or equal to, so we have a dashed. Okay. Now, when it is in the format of y equals mx plus b, we have a greater than, shade above. It's that simple. There's our graph. Okay? Because it's a greater than, because it's in that form y equals mx plus b, that's all you need to do, all you need to look at. And again, if we test that point, 0, 0, plugging in 0 for x and for y, 0 is greater than -2. So 0, 0 is above the line. We tested it. It made it true. That's why we shaded above. Okay. And we'll do the one on the right real quick. We graph it, y-intercept of 5, slope of 2. I'm just going to go the opposite way. So down 2 over a -1. It is an or equal to. So we have a solid line. We have y values less than. So we're going to shade below the line. And that's the graph. Again, you can interpret these inequalities here, again, only when it is y equals mx plus b form. Otherwise, you have to test a point. If we test at 0, 0, 0 is less than 5. 0, 0 is below the line, just like we shaded before. Okay, so horizontal and vertical inequalities. These are fairly simple if you remember what horizontal and vertical equations look like. When it is in this format, x equals a number, that's your vertical line. So just like with the other equations, graph it. We have x values less than or equal to -2. So it's a vertical line through -2 or equal to, so it's solid. There's our line. We want x values that are less than that. That's over here. -3, -4 x values. They're on this side of that line. That graph is done. When you have an equation of this format, y equals a number, that's horizontal. So we got, it is not an or equal to, so we're going to have a dashed, but it's a horizontal line through the y-axis at 1. We want y values greater than that, so that's above. And that's all it is. All right, that is it for the notes today. Let me double check. Yep, that's what we'll start with tomorrow. That's it. Have a good night.